Hello everyone, in this video I am going to demonstrate you an SMPS working on 110 volts AC to 220 volts AC and an output voltage of 27 volts DC. So this is the SMPS, and here you can see I have made some changes in the power circuit of this SMPS. I am having two half bridges in the power transformer input and two half bridges in the power transformer output. These two MOSFETs are IRF840 MOSFETs. You can see here these are IRF840 MOSFETs, and these are also IRF840 MOSFETs. So basically the input switching is done by MOSFETs and the output switching is also done by MOSFETs. And these MOSFETs are connected to the main power transformer. You can see here this is the main power transformer. The input to the transformer is fed by these two half bridge MOSFETs, and the output of this transformer is again fed by these two MOSFETs in half bridge mode. So the input of the transformer and the output of the transformer both are in half bridge mode. And it is to be noted that this transformer input and output both are center tapped. The input section is center tapped with the 125 volt DC bus, and the output section is also center tapped with the positive terminal. I am using a choke that controls the ripple, and these are the two filter capacitors. You can see that I am not having any Schottky rectifier to rectify the output. I am using the same IRF840 MOSFETs in the whole circuit. I am not having any Schottky rectifier, you can see. So this is the control part of the SMPS. This SMPS is designed with ICTL494 and it is operating at a frequency of 53 kHz. And the output of this oscillator is fed to this driver transformers. Is fed to this MOSFETs, and these MOSFETs are driving this initial driver transformer. So you can see here this is a driver transformer that controls these input half bridge and the output half bridge as well. So this oscillator built on ICTL494 basically drives a driver transformer, and the output of this driver transformer finally drives the half bridge power stages. You can see. So this is how the circuit works, and the output of the circuit you can see here is sampled with a 10K and 1K voltage divider network, and it is fed to the pin number 1 of ICTL494. So basically this is how the circuit is designed, and I have connected a load. You can see here this is the LED. You can see here this is the small LED chip, and this is, you can see here, this is the small LED chip, and this is 50C4000F. You can see. So this chip I am using to verify the load. You can see here. So this is how my entire setup looks like. So now I am going to power up the setup. So I am switching on the control supply. You can see my circuit is powered with a control supply. This is my control supply, and my 110 to 220 AC is fed to this rectifier block, and finally I am getting it in the board here. So now let us power up the circuit. I am going to power up the control supply. I have powered up the control supply. So now I am going to power up my variac. So I have powered up my variac. You can see here the voltages are 0 volts. This is the output voltage and this is the control voltage, and here you can see this is my load. So now I am going to increase my variac. You can see the output voltage will increase. The output voltage is increasing. You can see the control voltage is also increasing. You can see here it is 1.3 volt, the control voltage. So now I am further increasing. You can see here. You can see my LED lamp is now started to glow at a voltage of 25 volts. You can see here. You can see here. So now I am increasing further. You can see my LED lamp is glowing. The circuit is working. And now let's go to 220 volts. You can see I am increasing further. You can see the input voltage is increasing, but the output is rock steady. Now I am at 220 volts. You can see this is how the setup is. The control voltage is 2.5 volts. Let's see the ripple. How much is the ripple? You can see the ripple is very less, 80 millivolts AC ripple I am having. So let's go back to the output. You can see You can see the LED lamp is glowing. So let's now reduce the voltage. I am reducing the voltage. I have reduced the voltage to 0, as you can see. So this circuit is tested circuit and it is using H-bridge configuration in both the inputs and the outputs, and I am going to add all the description, circuit diagram, everything in the description link. All the circuit diagrams related to this project is published in my website and everything can be downloaded from there. I am attaching the description link. Thanks a lot. Thanks for watching. Thank you so much.